Find the interval in which this function is increasing or decreasing. So here fx is 4 sin x minus 2x minus x cos x upon 2 plus cos x. So that is, now simplifying this function before starting differentiation from last two numbers in numerator. If we take x common, then we will have 2 plus cos x that can be cancelled with this number. So 4 sin x minus 2 minus x common into bracket 2 plus cos x upon 2 plus cos x. So 4 sin x upon 2 plus cos x minus dividing second term by this number x. So this is fx. Before taking differentiation, we have converted in simple form. And now f dash x. F dash x is u by v. So derivative of this number v square. V as it is. Derivative of u is 4 cos x minus 4 sin x as it is into derivative of a denominator is minus sin x. So this is derivative of this first term minus derivative of x is 1. So simplifying this, 4 cos x into 2, 8 cos x plus 4 cos square x plus 4 sin square x, 4 common, so cos square plus sin square upon 2 plus cos x whole square minus 1. So this is equal to 8 cos x plus 4 upon 2 plus cos x whole square minus 1. Taking here LCM, 2 plus cos x whole square LCM, 8 cos x plus 4 minus, this will be multiplied with 1. So 2 plus cos x whole square. So simplifying this, it is 8 cos x plus 4 minus 4 cos x minus cos square x upon 2 plus cos x whole square. Now this 4 cancel. 8 minus 4 cos x is 4 cos x minus cos square x upon 2 plus cos x whole square. That is equal to cos x common 4 minus cos x upon 2 plus cos x whole square. Now see, in the question, domain of function is R. No any particular interval is given. Here a domain is R. X is anti-real. So we have to discuss on set of real numbers, that is whole real line. So we shall find out the intervals of this set of real numbers in which function is increasing or in which intervals function is decreasing. So we have to check sign of f dash x. So see, here look this bracket, 4 minus cos x. Cos x is always between minus 1 and 1. This cannot be more than 1. So this is always positive. This is also positive. So as cos x has value between 1 and minus 1, 4 minus cos x is always is greater than 0, and this is obviously positive. This is obviously positive. So positive upon positive, therefore positive upon positive is positive. So this part is positive. So sine of f dash x, sine of, this is the value of f dash x. Sine of f dash x depends on sine of cos x. So when cos x is positive, f dash x will be positive, and when cos x is negative, f dash x will be negative. So here, therefore, sine of f dash x depends on sine of cos x. So when cos x is positive, at that time f dash x will be positive, and when cos x is negative, at that time f dash x will be negative. So this is the meaning of this statement. Sine of f dash x depends on sine of cos x. Cos x positive, double implies f dash x positive, and cos x negative, double implies f dash x negative. So that is, this is the possibilities. Now, first of all, we take case 1. Now look, cos x is positive. Cos x is positive in first quadrant. In second quadrant, cos x is negative. Third quadrant, cos x is negative. Then again in fourth quadrant, cos x is positive. So here we discuss intervals on number line. Say, this is unit circle. On unit circle, this point is point corresponding to 2k pi. K is an integer, or we can say 2n pi. This is 2n pi, where n is integer. This is 2n pi plus pi by 2. This number will be 2n pi plus pi. This number can be taken as 2n pi plus 3 pi by 2. And this number again can be taken as 2n pi plus 2 pi. So beginning from 2n pi to 2n pi plus pi by 2 covers first quadrant. Then 2n pi plus pi by 2 to 2n pi plus pi covers second quadrant. Then from this number to this number it covers third quadrant. And from this number to this number it covers fourth quadrant. In first quadrant, cos x is positive. In second quadrant, cos x is negative. In third quadrant, cos x is again negative. Here, cos x is positive. So, set of a real number can be divided in intervals in terms of any integer n. So say, now I am taking these intervals. Now see, these are the points. These are the points at which cos x equal to 0. Here, cos x, value of cos x equal to 0. Now see, case 1. Case 1. If x belongs to, if point corresponding to x lies in first quadrant, point corresponding to x lies in first quadrant, point corresponding to x lies in first quadrant, that means x belongs to 2n pi to 2n pi plus pi by 2. That is x belongs to 2n pi to 2n pi plus pi by 2. N belongs to z. 2n pi to 2n pi plus pi by 2. That is, it covers first quadrant. Like suppose if you keep 0, so this will be 0 to pi by 2. If you keep here 1, so it will be 2 pi to 2 pi plus pi by 2. If you take here 3, 6 pi to 6 pi plus pi by 2. So this interval defines not only any one particular interval, it defines so many intervals. If x is in this interval, then cos x is positive. Cos x is positive, so after as x is more than 0. So that is now say if I include this number, then here cos x equal to 0. So if I include 2n pi plus pi by 2, now say including this number, then cos x is more than or equal to 0. Cos x is more than or equal to 0. That is this interval putting in simple form 2n pi comma 4n plus 1 times pi by 2. So in this interval, cos x is positive. Cos x is positive. Cos x is positive, so after as x is more than 0. Here, because we are including this number, it can be equal to 0. Cos x is more than or equal to 0, so after as x is more than or equal to 0. When cos x is less than or equal to 0, after as x will be less than or equal to 0. So here, after as x is more than or equal to 0, so function is increasing. Function is increasing in this interval. So function is increasing in 2n pi comma 4n plus 1 times pi by 2. Keep here close. If we put here open interval, that means this point is excluded. That means cos x is greater than 0. Then we should keep here strictly increasing. So it was case 1. Now case 2. If point corresponding to x lies in second quadrant, if point corresponding to x lies in second quadrant, then x belongs to, this is second quadrant. If point is anywhere on this part, second quadrant, then it covers 2n pi plus pi by 2 to 2n pi plus pi. 2n pi plus pi by 2 to 2n pi plus pi. Now this point I keep close, here open, because here cos x is equal to 0 and in the remaining part cos x is negative. So that means x belongs to 4n plus 1 times pi by 2, 2n plus 1 times pi, open. So in this interval, cos x is less than or equal to 0. So function is decreasing function. This function is decreasing function in close 4n plus 1 times pi by 2 comma 2n plus 1 times pi. Then case 3. If px lies in third quadrant, if px lies in third quadrant, px lies in third quadrant implies x belongs to 2n pi plus pi comma 2n pi plus 3 pi by 2. 2n pi plus pi to 2n pi plus 3 pi by 2. In this interval, it covers third quadrant. Cos x is negative. And here cos x equal to 0. So if I include this point, if I keep here close, then we can say in this interval, cos x is less than or equal to 0. So x belongs to 2n plus 1 times pi, comma, 4n plus 3 times pi by 2 close. So this interval cos x is less than or equal to 0. So this function is decreasing in open interval 2n plus 1 pi 4n plus 3 times pi by 2 close. Then case 4. Case 4. If px lies in fourth quadrant, if px lies in fourth quadrant, point corresponding to x lies in fourth quadrant, then x belongs to 2n pi plus 3 pi by 2. See, I am including that number 2n pi plus 3 pi by 2, comma 2n pi plus 2 pi, 2n pi plus 2 pi the over. So in this interval, 4n plus 3 times pi by 2, comma here 2n pi plus 2 pi, 2 pi common, so 2 into n plus 1 times pi. So in this interval, cos x is greater than or equal to 0. Cos x is greater than or equal to 0, so function is increasing function. In the interval 4n plus 3 times pi by 2, comma 2 into n plus 1 times pi. So this interval, it is not any particular interval. As you change value of n, changing value of n every time we are getting new intervals of it. It represents a group of intervals. So in all such type of intervals where n is any integer, function is increasing. And similarly for all these cases. So in every case, n is integer. In everywhere, n is integer. N is integer. If domain of f is 0 to pi, if this interval is given in question, then 0 to pi, so 0 to pi by 2 covers first and second quadrant. So this is first quadrant. So 0 to pi by 2 in first quadrant, function is increasing. So in 0 to pi by 2, here in this interval, cos x is more than or equal to 0. So function is increasing. And in pi by 2 to pi by 2 to pi, here cos x is less than or equal to 0. So function is decreasing. It covers second quadrant. In second quadrant, function is decreasing. If you remove this closed interval, then cos x will be strictly greater than 0. If you remove this closed interval, it will be strictly less than 0. In that case, here we put word strictly increasing. Function is strictly decreasing. Show that the normal at any point theta to the curve x equal to a cos theta plus a theta sin theta, and y is equal to a sin theta minus a theta cos theta is at a constant distance from the origin. Say here x equal to a cos theta plus a theta sin theta. We are finding equation of normal at theta point. So x equal to a cos theta plus a theta sin theta. So differentiating with respect to theta, derivative of a cos theta is minus a sin theta plus here u into v. U as it is, derivative of sin theta is cos theta plus sin theta as it is, derivative of a theta is a. So it is equal to minus a sin theta plus a sin theta will be cancelled. So a theta cos theta. It is dx by theta. And y is equal to a sin theta minus a theta cos theta. Now differentiating with respect to theta, dy by d theta is equal to a as it is, derivative of sin theta is cos theta minus here u into v in bracket. U as it is, derivative of cos theta is minus sin theta. So a theta into minus sin theta, that is minus a theta sin theta plus cos theta into derivative of a theta is a. So it is equal to a cos theta will be cancelled. So it is a theta sin theta. This is dx by d theta. This is dy by d theta. So from 1 and 2, dy by dx is dy by d theta upon dx by d theta. Dy by d theta is a theta sin theta. Dx by d theta is a theta cos theta. So this is tan theta. Dy by dx is tan theta. Therefore, slope of, now we want equation of normal. So slope of normal at any point theta is, slope of normal is minus 1 upon dy by dx. Slope of tangent is dy by dx. Slope of normal is minus 1 upon dy by dx. So it is minus 1 upon tan theta. So it is minus cot theta. So it is slope of normal. Now equation of normal at any point theta. At any point theta, that is at, so this is x coordinate of theta point and this is y coordinate of theta point. So a cos theta plus a theta sin theta comma a sin theta minus a theta cos theta. This is theta point, x coordinate of theta point, this is y coordinate of theta point. So at any point theta, that means at this point, equation of normal is y minus y1 equal to n into this is x slope into x minus x1, that is a cos theta plus a theta sin theta. Now simplifying this will be then y minus, say, this is minus x cot theta. That term I am taking on this side. So it will be x cot theta into x plus, this is y plus y. So cot theta into x plus y, then minus a sin theta plus a theta cos theta, then minus cot theta into minus of this number that will be shifted on other side, or for a few minutes let me take this as it is. This number we give as it is. Now this number, after multiplying with this, we shift on other side. So it will be, say, minus cot theta into minus is plus cot theta. So taking on that side, it will be again minus cot theta into a cos theta plus a theta sin theta equal to 0. Therefore, now cot theta is cos theta by sin theta into x plus y minus a sin theta plus a theta cos theta minus, this is cos theta by sin theta into a cos theta plus a theta sin theta equal to 0. Now multiplying this by sin theta, multiply by sin theta, cos theta into x plus sin theta into y minus a sin square theta plus a theta sin theta cos theta minus cos theta into cos theta, a cos square theta minus a theta sin theta cos theta equal to 0. So this will be cancelled. So simple form is cos theta into x sin theta into y minus a sin square theta minus a cos square theta, that is minus a common sin square theta plus cos square theta equal to 0. Therefore cos theta into x plus sin theta into y minus a is 0. It is equation of normal. This is equation of normal at any point theta, which is equation of normal at any point theta. Now in this question, we want its a distance from origin. So it's a distance from origin P is equal to modulus distance from origin, that is distance of any line from 0, 0, that is modulus C upon root a square plus b square cos square theta plus sin square theta. Distance of any line ax plus by plus c equal to 0 from origin is modulus C upon root a square plus b square. So this is a. So it is constant. This is modulus A. And it is constant. So remember, in this last step, we have used this result. Distance of any line ax plus by plus c equal to 0 from origin is p equal to modulus c upon root a square plus b square. This result is used. This is used.